Hello student, today we will discuss about drying agents basically. Okay, some reasoning questions are here. Reason why calcium chloride cannot dry. Ammonia, amines, alcohols, phenols, aldehyde, ketones. You have to write down all these names, 6 and 7 is semester. Okay, reason is that all of them they will form adduct with ammonia. I have given only one example, CaCl2.4 NH3. You need not to require to know all the adducts, but simply you think about that they are forming adducts. That is why CaCl2 cannot dry all of these 7 compounds. So they are substances are all the above compound substances are bound by CaCl2. But you know, CaCl2 has 98% bonding capacity with water. Okay, why? Because it will form hydrated salt with water. So all of them, these 7 cannot be dried by CaCl2, but moisture can be removed by using CaCl2. It is a very good dehydrating agent to remove moisture, traces of water from the given environment, from the solution, etc. Now hydrated salts on being heated give back to CaCl2. What does it mean? Means when it is forming a hydrated salt, then at normal temperature it is forming hydrated salt. But if it is heated, that hydrated salt is heated, that water of crystallization will be removed, and then we will get anhydrous CaCl2 back. It means the reaction of CaCl2 with water is reversible reaction. Okay, and on heating we will get back the anhydrous salt. That is why we have to be very careful about dealing with it. We have not to heat that reaction mixture when we are using CaCl2. Okay, to dry the given solution. Now P4O10 or P2O5, that is phosphorus pentoxide, also cannot dry ammonia. Why? I told you that CaCl2 cannot dry ammonia, and now I am saying that P4O10 is also do not dry ammonia, because P4O10 phosphorus pentoxide is acidic in nature and ammonia is basic in nature, so it will form salt. Ammonium phosphate will be formed. PO4 it is. Okay, this is PO4. Ammonium phosphate will be formed. That is why we are not using P4O10 or CaCl2 with ammonia. The reason is different. In that case, calcium chloride is from adduct, but in P4O10, when we are using P4O10, it will form acid-base reaction and will get ammonium phosphate. I have written over here. So P4O10 being acidic in nature and ammonia is basic in nature, so acid-base reaction will occur and will get phosphate, salt, ammonium phosphate. Clear to you? Now we'll do here. See, now drying agent or desiccant, we can use drying agent or desiccant also. The second name is desiccant because drying agents are used in desiccator. That is why name is coming from that desiccator. Now CaCl2 dries neutral gases. Now here there are so many questions I have written in the form of understanding, so that you can learn it. And one question always comes in the exam, any competitive exam, whether it is NEET or IIT or GATE or any other competitive exam. Okay, now quick lime, CaO or soda lime. Soda lime is mixture of NaOH and CaO, 1:1 ratio. Okay, they both are basic in nature. So sometimes they are asking, write down 2 basic drying reagent. At that moment you have to learn about this, and you have to say that CaO and sodium hydroxide, soda lime, all these are drying agents. Okay, now they are basic in nature, so they can dry ammonia gas. Now they will give you in MCQ, they will give you so many different drying agent, and they will ask which will dry ammonia. So quick lime and NaCO will dry ammonia because both of them are basic in nature, so there will be no effect on it. What is quick lime? CaO is quick lime. What is soda lime? NaOH CaO mixture is known as soda lime. Okay, now explain why see this question is again and again coming, because this is very important and not used to dry ammonia. So I have written CaCl2.4 and NH3 adduct is formed, so it is not used in this case, but instead CaO and soda lime is used. Now question arises, what is the role of anhydrous ZnCl2 in Lucas reagent? We are using Lucas reagent during the time of testing of alcohols. So at that moment, this anhydrous ZnCl2 act as dehydrating agent. You know, this reaction of alcohol with this HCl, conc HCl is a reversible reaction, but in presence of ZnCl2, the reaction shifts only in the forward direction because the other product is water. So water is removed by the anhydrous ZnCl2. So reaction favors, the equilibrium favors forward direction only. Do you understand this point? Write down all these points and then I will move again. Okay, now we have to go for, did you write it? Okay, now I'll do the different things. See, now I will tell you this. Conc H2SO4 acts as drying agent as well as dehydrating agent. You know, it is used in desiccator as well as we have seen that so many dehydration reaction we have done in case of alcohol. It removes water from the alcohols and form alkane. Clear? Now see here, removes traces of water if present in the preparation of Grignard reagent. Now question was, which reagents are used to remove water from the Grignard reagent preparation during the time of preparation of Grignard reagent? Question was very lengthy. I have given you only answer. So calcium hydride and lithium aluminum hydride, that is metallic hydride, removes traces of water present in the during the preparation of Grignard reagent. We are mixing with dry ether, we are mixing this and then we are preparing Grignard reagent. Otherwise what will happen, as Grignard reagent form, if there will be water, it will immediately react with water. It is highly reactive with water. So instead of getting anything, we will get alkane, and the purpose of the our motto will be not solved. We cannot means Grignard reagent will react it with water. That's it. It will not react with aldehyde and ketone, etc. Now dry erite. That dry erite, calcium sulfate is known as dry erite. Always they are using dry erite instead of calcium sulfate. Okay, so this is used in desiccator. So three things you remember, that P4O10 can be used in desiccators, this dry erite, that is calcium sulfate, can be used in desiccator, and conc H2SO4 can be used in desiccator. Right? Now desiccator, I told you that it is apparatus in which we are putting some precipitate or some important compounds which is formed and which we have to prepare, prevent them from water or moisture, so that we are putting conc H2SO4 or P4O10. Here I told you calcium sulfate also. We are putting this inside the desiccator. They are not in direct contact of the given compound or the given solution. They are just putting inside the apparatus, desiccator, and they will absorb water present in the desiccator, moisture present in desiccator. See, why I told you that P4O10 is used. See, P4O10 react with water and it will form H3PO4, that is phosphoric acid. So traces of water from the desiccator can be removed. Now, how Na2SO4 works? How Na2SO4 is used in acid drying? See, whenever I am saying this, always remember that they are anhydrous. Sometimes I have not written all the times. It is not, all these salts are anhydrous. Then only they can absorb water. If they are already hydrated, why they will absorb water? See, Na2SO4 anhydrous, Na2SO4 takes out 10 water molecule, because water of crystallization of sodium sulfate, this is hydrated salt, is 10. That is why, and it is fixed. It is fixed. It will not absorb 5, 6, 8. It will absorb 10 water molecule, and each molecule will absorb 1 mole. We can say 1 mole of Na2SO4 absorb 10 mole of water molecule. That is why water of crystallization of sodium sulfate is 10. Okay, hydrated salt is 10. So this is called water of crystallization. This is anhydrous salt and this is hydrated salt. Hydrated salts are those salt which are chemically bonded with the X number of water molecules, because X is the number. Every anhydrous compound has different crystallization of number. Okay, so water of crystallization is 10 in this case. In case of MgSO4 it is 7. In case of copper sulfate it is 5. I will discuss it later on. Now this reaction is always anhydrous to hydrated salt turning. It is always reversible reaction. At low temperature they will form hydrated salt. When the solution mixture it is heated, then it will come back to this original anhydrous salt. That is why temperature must be maintained. We have to see the temperature, because at a high temperature reverse reaction will proceed. Okay, so whenever drying agent we are using and it is from this, immediately we'll remove it. Before heating the solution, reacting mixture, we have to remove this hydrated salt as it is formed, and now we have to go for heating, so we have to remove the filtering, all these things, and we have to remove by the practical methods. Now calcium oxide is drying agent in the preparation of ammonia. That is very important. See, this is a drying agent only for calcium oxide, because calcium oxide is basic in nature. It is basic drying agent. Calcium oxide is basic drying agent, so it will remove ammonia from the moisture from the dry ammonia. It makes ammonia dry. During the preparation of ammonia, if some certain amount of moisture will be there, so it will form ammonium hydroxide. Instead of ammonia, we'll get ammonium hydroxide, because ammonia combined with water. And that is why we have to make this dry ammonia. We have to keep pass it through calcium oxide. So water, if some water is absorbed by this, it can be catched by the calcium oxide. It can be absorbed by the calcium oxide. Now some question can be like this also: alkane and alkyl halide, how can you dry them? So I have used here 5 things. See here, always you have to see that calcium chloride, P4O10 and H2SO4 always coming almost in every examples. Okay, there, because I told you H2SO4 is drying agent as well as dehydrating agent, and using MgSO4, CaCl2, 2 sulfates and sulfuric acid, P4O10, CaCl2. What does it mean? H2SO4 is acidic drying agent, P4O10 is acidic drying agent, CaSO4 and CaCl2 they are neutral. And NGSO4 is also neutral, means substance. So H2SO4 and P4O10 are acidic drying reagent. Thank you for watching. God bless you.